This lecture video is about activity 4.5 and it's called What Goes Up Comes Down. So this is some more stuff about quadratic functions. When you kick a soccer ball up into the air, gravity acts on the ball and opposes the upward force of your kick. If the ball leaves the ground at a speed of 64 feet per second directly upward, then the algebraic rule that describes the height of the ball as a function of time is h of x equals negative 16x squared plus 64x, where x represents the number of seconds since the kick, and h of x represents the ball's height in feet above the ground. Since the expression negative 16x squared plus 64x is a second-degree polynomial, the height function is a quadratic function. We want to use the algebraic rule to complete the table. So at 0 seconds, if I plug 0 into both of these x's, then we'll get 0. And then if I plug in 0.5, we'll get negative 16 times 0.5 squared plus 64 times 0.5. And 0.5 squared is 0.25, and then times negative 16 gives you negative 4. And then plus 64 times 0.5 will give you 32. And let's just break out our calculators here, and negative 4 plus 32 gives us 28. And if we plug 1 in there, we get negative 16 plus 64. Which gives us 48. Excuse me. And if we plug in 1.5, negative 16 times 1.5 squared plus 64 times 1.5. So what do we get for our first term here? We get 1.5 squared times 16. So that'd be negative 36 plus 64 times 1.5 gives us 96. And when we add those together, we get 60. And now plug in 2, negative 16 times 2 squared plus 64 times 2. 2 squared is 4, and so we have negative 16 times 4, which gives us negative 64. And 64 times 2 is 128. Excuse me. And negative 64 plus 128 gives us 64. And then we want to plug in 2.5, so negative 16 times 2.5 squared plus 64 times 2.5. 2.5 squared times negative 16 gives us negative 100 plus 64 times 2.5 gives us 160, and so that'll be 60. And then we want to plug in 3, negative 16 times 3 squared plus 64 times 3. We'll get negative 16 times 9 gives us negative 144 plus 3 times 64 is 192. Minus 144 gives us 48. And then we want to plug in 3.5, negative 16 times 3.5 squared plus 64 times 3.5 And so we're going to square 3.5 and multiply that by 16, negative 16 in fact. That's negative 196 plus 64 times 3.5 gives us 224. And minus 196 gives us 28. And then plug in 4. Negative 16 times 4 squared plus 64 times 4. And 4 squared is 16, so we have 16 times negative 16. And that's negative 256. Plus 64 times 4 gives you 256. Whoops. And so that is 0. All right, so there is our filled-in table. What does h of x equals 0 signify? So remember, h of x is the height of our ball. So what this means is that the height of the ball is 0 feet. Or the ball is on the ground. Explain why the heights increase and then decrease. So you kick the ball, which forces the ball to go up. Excuse me. And then good old gravity works on the ball. And the first thing that the gravity does is it slows the ball down. And eventually the ball actually stops very briefly, and it stops going up and it starts coming down. And that's why at first the height of the ball goes up. It goes up until gravity stops the ball, and then gravity keeps on working on the ball, pulling it back down to the Earth's surface, and so the height then will start to decrease. Now we want to sketch the graph of this using the table of plotted points that we had, and then draw the curve through them. And we want to make sure that we scale our axes appropriately. So x is time, and that's in seconds. And h of x is the height of the ball, and that's in feet. Okay, so we need to go from 0 to 4 on the x-axis. 1, 2, 3, 4, 5, 6, 7, 8. So they gave us more than 8, so we'll go every other. 1, 2, 3, 4, 5. So each tick mark is 0.5. And then we need to go from 0 at least up to 64. And I'm going to assume that that's going to be the highest point. 0 to 64 on the y-axis. And they gave us 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And let's see what we get when we divide those. 64 divided by 11 gives us 5.8. So we need to use at least 6, but is there some number that's going to make things kind of nice for us? And it needs to be at least 6. So 8 wouldn't be too bad. There's a couple of them then that would fall right on the axes, or 10 might not be too bad. If we went with 10, then we'd only be going halfway up, so why don't we just go with 8? So that would be 16. So every other tick mark is going to be worth 16. So 32. Then add another, that's 48. And then add another. Oops. Gives us 64. And that was as high as we needed to go. So our first point was the point 0, 0. And then we had the point 0.5, 28. So 0.5, and these are all worth 8. So this would be 24, and half of that is going to be 4 more, so half of that is going to be 28. So that works out pretty nice. And then we have 148, 0, 0, 0.5, 28. And then we had 148. And then we have 1.560. So let's see, what would this one be? If I add 8 to that, I would be at 56. So halfway between there would be 52. And what point am I plotting again? 60. So that's 4 more than that. So here's 60. And did I accidentally... Nope, that one's right. 1.560 it was. And our next one is 264. Nice, easy point for us to plot. And then we've got some symmetry stuff going on, so these will all be pretty easy too. So 2.560. And then it was 348. And then we have 3.528. And then we have 40. Okay, and then we want to connect these points with a nice smooth curve. And there we go. So there is our parabola. And then we want to use a graphing calculator to produce the graph of this function. And so we want to use the same window. So we want to go from 0 to 4 on the x-axis, and then it actually tells us to go from 0 to 80 on the y-axis, because we want to make sure that we see the tip do an x scale of 0.5 and a y scale of 10. So let's bring up my graphing calculator here. Alright, so I still have all the old stuff in there from before, so I need to go to the y equals menu, and I need to clear out that function and type in our new one. So our new one is negative 16x squared plus 64x. Oh, did I hit the wrong button? So I accidentally hit multiplication here, so when I have my cursor blinking on it, I can change that to addition just by moving it into the right place. So there we have our new function in there. Now I need to go to the window, so click on the window button, and we need to reset our window. We want to graph this from 0 up to 4 on the x-axis. And we want our x scale to be 0.5, we already have that. And then we want to go from 0 up to 80, so change this 400 to 80 on our y-axis. And what do we want our y scale to be? 10. So change that to 10. And now I'm going to go hit the graph button and see what I come up with. And so there we go. We have a nice graph here. And it looks similar to the graph that we did on our paper. And here we just have all the instructions on how to do this. All of these grayed in things are buttons for you to push on your calculator. So hopefully that will help you remember how to get through graphing on your graphing calculator when you're by yourself. So now I'm going to look at solving equations that have the form ax squared plus bx equals 0, where a is not equal to 0. So the graph of h of x equals negative 16x squared plus 64x is a parabola whose graph rises and then falls. How many x-intercepts or points at which the graph intersects the x-axis does this graph have? So we'll just bring my calculator back up. So here's the x-axis right here. And so notice it crosses right here and right here, so in two places. And so it has two x-intercepts. And what are their coordinates? The first one was 0, 0, and the other one was at 4, 0. So we can go up to our graph that we did on paper and see that pretty easily. At 0, 0 it crosses, and right here at 4, 0. What do these x-intercepts signify in terms of the soccer ball? Well, this is when the soccer ball, notice these two values are the same, and that is the h of x value, and so it's when the soccer ball is on the ground. Okay, the x-intercepts have an algebraic interpretation as well. When the soccer ball is at ground level, its height h of x is 0. Substituting 0 in for h of x in the formula h of x equals negative 16x squared plus 64x results in a quadratic equation. 0 equals negative 16x squared plus 64x, or, equivalently, negative 16x squared plus 64x equals 0. Note that you cannot solve this equation by the reverse sequence of operations. The difficulty here is that the input variable x occurs twice in two distinct terms, the negative 16x squared and in the 64x. These two terms are not like terms, so they cannot be combined. However, both terms share common factors. Their coefficients are both multiples of 16, and they each have at least one factor of x. So we're going to look at using our GCF, or greatest common factor, which is a common factor such that there are no additional factors common to the terms in the expression. Determine the greatest common factor of negative 16x squared and 64. So they already stated that 64 was a factor of 64. So let's just see what happens when we take 64 and divide it by 16. We get 4. So 16 is the largest number that divides both 16 and 64. And this has 2 x's, but this one only has 1, and so what they have in common is the 1x. So 16x is the GCF. And in most of these, where they're talking about kicking a ball or dropping an item, most of the time this 16 is going to divide this other number here. Typically they do anyways. Or you'd at least want to check that. So use the greatest common factor to write the expression on the left side of the equation, 16x squared plus 64x equals 0 in factored form. So we can factor out a 16x. And so again, remember that's taking both of these terms and dividing it by 16x, and that's what will go in my parentheses. So let me just change the color there. And negative 16x squared divided by 16x. The 16s will cancel. This x cancels with one of those x's, and so we're left with negative x. And here, 16 goes into itself once and into 64 4 times. Remember, we just did that on our calculator. And now these x's cancel, so all I'm left with is plus 4. Okay, the solution of this equation, and we need the equals 0, don't forget that. The solution of this equation depends on a unique property of the 0 on the right-hand side of the equation. So, and it's called the zero product property. If the product of two factors is 0, then at least one of the factors must also be 0. If we write that symbolically, if you have two things, a times b, and you're multiplying them, and it equals 0, then either a has to be equal to 0 or b has to be equal to 0. So the only way for you to multiply two things together and get 0 is if one of them is 0. Okay, so we're going to use that property to solve this. So we want to take 16x, let it be equal to 0, and then solve this for x. We would divide both sides by 16. And remember that 0 divided by anything is 0, so it gives us 0, x equals 0. Also, we have plain old number 16 can never be 0, so we know that x has to be 0 because one of them has to be 0 for us to get 0 when we multiply two things together. Here we have negative x plus 4 equals 0. So since this is negative x, I want to add x to both sides. This is the easiest way to solve this one. And so that will give me x equals 4. And that was what we saw before, that our two x-intercepts were at x equals 0 and x equals 4. Verify that each solution in parts A and B satisfy the original equation, negative 16x squared plus 64x equals 0. So negative 16 times 0 squared plus 64 times 0. Is that going to give us 0? Sure. 0 squared is 0, and anything times 0 is 0, so we get 0, and then 64 times 0 is 0. And yes, that does, in fact, give us 0. And what about 4? So we have negative 16 times 4 squared plus 64 times 4. We want to know, is that equal to 0? And 4 squared is 16, so we have negative 16 times 16. And 64 times 4 gives us 256. So I'm still going to put my question mark above my equal sign because I still don't know if that's true or not. And let's multiply 16 and negative 16 together and see what we get. 16 times a negative 16 gives us negative 256. plus 256 does in fact give us 0, and so that one works as well. Now we're going to use this property to solve each of these equations. So we already have this one factored, x times the quantity x minus 3, so we're just going to take each of these factors and set them equal to 0. So x equals 0, and then x minus 3 equals 0. And for this one, we just have to add 3 to both sides, and we get x equals 3. And the other solution was x equals 0. This next one, x times the quantity x plus 5 equals 0. So do the same thing that we just did. So take this x, let it be equal to 0. So that gives us a solution x equals 0. And then take this x plus 5 and set that equal to 0. And to solve that, we would subtract 5 on both sides, giving us x equals negative 5. So we have two solutions here, x equals 0 and x equals negative 5. Do the same thing on our next one. Here we have the quantity x minus 2 times the quantity x plus 2. So first we're going to take x minus 2 and set that equal to 0. Next we're going to take this x plus 2 and set that one equal to 0. And so we're going to subtract 2 from both sides of the second one, and that gives me x equals negative 2. And then for the second equation, we're going to add 2 to both sides of the equation, giving me x equals positive 2. So this time our two solutions were 2 and negative 2. And now this time we have to factor out the GCF first, and then we're going to set each of our factors equal to 0 and solve just like we did with the last three. So here it's x squared minus 10x equals 0. And this one doesn't have any number. Well, there's an implied 1 there, but there isn't anything that we need to factor out of there. They both have x's. This one has 2 x's. This one only has 1. And so our GCF is going to be just x. And remember, you're dividing both of these by x, and that's what goes in our parentheses. So x squared divided by x gives me x, and negative 10x divided by x gives us minus 10. So now we're going to set this first part equal to 0. That gives me the solution x equals 0. And then we're going to set this x minus 10 equal to 0. And we would add 10 to both sides. And it gives us the solution x equals 10. Now in the next one, this is very similar. We have x squared plus 7x equals 0. So we're going to do the same thing. Find the GCF. Again, there's no number other than 1 in front of the x squared, so we can't factor out a number part. But we do have an x squared and an x, and so the smaller of those is the x, so that's what we can factor out. And again, don't forget that this means that we're dividing these by x, and our result goes in the parentheses. X squared divided by x is x, plus 7x divided by x is 7, and then that's equal to 0. Now, set this x equal to 0, and that gives us our solution x equals 0, and then we're going to take the x plus 7 and set that equal to 0 as well. Subtract the 7 from both sides, and we get another solution, x equals negative 7. Now on to example C. We have 2x squared minus 12x equals 0, and the first step is to find our GCF. So both 2 and 12 are divisible by 2. So the number that will divide both of them is 2, and then we have x squared and x, and you need to take the smaller of those, so that's just an x. So 2x is our GCF. And so really we're taking these both and dividing them by 2x, and that's what we're going to put in our parenthesis. And so these 2's cancel, and x squared divided by x is x. And the 2 here goes into Oh, and I don't know why I have a negative sign there. I shouldn't. 2 goes into itself once, and into this into this 12 6 times. We're going to have minus, and these x's cancel. Minus 6. And it's equal to 0. And then we do what we did before. We take this 2x, set it equal to 0, and divide by 2 on both sides. 0 divided by anything is 0, so we end up with a solution x equals 0. Now we're going to take this x minus 6 and set that equal to 0. Add 6 to both sides, and we get x equals 6. So our two solutions are 0 and 6. In the next example, we have 4x squared minus 6x equals 0. We need to find our GCF. And now we need the biggest number that will divide both 4 and 6. So the only numbers that divide 4 are 1, 2, and 4. And 6 is divisible by 2 and 3. And so our number GCF is 2. And then we have x squared and x. We have to take the smaller of those, which is 2x. So we're going to factor out a 2x. Remember, that's dividing these by 2x, and that's what goes in your parentheses. And so we're going to end up with 2x minus 3 this time. And back to setting each equal to 0. So if 2x equals 0, we would divide by 2 on both sides, and that gives us the solution x equals 0. And then we take 2x minus 3 and set that equal to 0. Add 3 to both sides. We get 2x equals 3, and then divide by 2. That gives us x equals 3/2, and you can leave it right like that as a fraction. So we have the two solutions, x equals 0 and x equals 3/2. Just have a couple more examples here for us to run through. In these, they have both terms on separate sides of the equation. You need to make sure that you have 0 on one side of these before you factor and set those factors equal to 0. So to end up with 0 on one side of this 2x squared equals 8x, I'm going to subtract the 8x from both sides. And that gives me 2x squared minus 8x equals 0. So now I can factor out my GCF. And the GCF here is going to be 2x. So again, we're dividing each of these by 2x, and that's what goes in our parentheses. So these 2's cancel, and this x cancels with one of those, leaving us with an x. And then minus, the 2 goes into the 8 4 times, and the x's cancel, so we have minus 4 equals 0. Now we take 2x and set that equal to 0. Divide by 2 gives us the solution x equals 0. Now we take the second factor, x minus 4, and set that one equal to 0. Add 4 to both sides, and we get x equals 4 as our other solution. Do the same thing to this one. We have 6x squared equals negative 4x. I want to make sure that I have 0 on one side, so I'm going to add 4x to both sides. That gives us 6x squared plus 4x equals 0. And I need the GCF. And again, 6 and 4, the biggest number that will divide evenly into both of those is 2, and we can also pull out an x. And so again, we're dividing both of these terms by 2x to figure out what goes in our parentheses, and 2 goes into 6 3 times, and this x cancels with one of those, so I'm left with 3x, and then plus, these x's cancel, and this 2 goes into this 4 twice, and so we're left with 3x plus 2. And it's equal to 0. Now we're going to take the 2x, set that equal to 0, and we divide by 2, we get x equals 0 as one of our solutions. And now we're going to take 3x plus 2 and set that equal to 0. Subtract the 2 from both sides, and we get 3x equals negative 2. And the last thing to do is divide by 3 on both sides, and it gives us the solution x equals negative 2/3. In an equation such as 3x squared minus 15x equals 0, it's always permissible to divide every term in the equation or both sides by some non-zero number. Here you see that dividing by 3 simplifies the original equation. So if we were to take all of these and divide everything by 3, then we would get x squared minus 5x equals 0. And so it just gives us excuse me, smaller numbers. Factoring, then applying the zero product property, leads to the following. So if I factor an x out, I'll be left with x plus 5, x minus 5 in my parentheses. And then we can do the same thing that we've done before. Set x equal to 0, that gives us one solution. And then set x minus 5 equal to 0 gives us x equals 5 after we add 5 to both sides of the equation. However, it's never permissible to divide through by a variable such as x everywhere. So what happens if we do that? Then we had 3x squared minus 15x equals 0. And so if I divide each term in this by x, then I would get 3x minus 15 equals 0. And I could factor a 3 out of there. That would give me 3 times the quantity x minus 5 equals 0. And this 3 can't be equal to 0, right? 3 is not equal to 0, so that doesn't give you anything. In fact, you could just divide by the 3 everywhere. And x minus 5 equals 0. We would add 5 to both sides. And it gives us, x equals 5. So we lost a solution. And that's why you cannot divide by x. Suppose that you kick a soccer ball directly upward at a speed of 80 feet per second. An algebraic rule that describes the height of the ball as a function of time is h of x equals negative 16x squared plus 80x, where x represents the number of seconds since the kick, and h of x represents the ball's height in feet above the ground. How high is the ball 2 seconds after it's kicked? So seconds is our time, and so we want to find h of 2. So negative 16 times 2 squared plus 80 times 2. So that is 16 times 4 gives us negative 64 plus 160. And that gives us 96. And so after 2 seconds, the soccer ball will be at 96 feet high. Write an equation that represents when the ball is on the ground. So the height of the ball when the ball is on the ground will be 0. So that means that h of x is 0. So we get 0 is equal to negative 16x squared plus 80x. And now we want to solve the equation from part B. And what do the two solutions signify in terms of the soccer ball? So we can factor out a 16x. And again, that's dividing both of these terms by 16x. So that would leave me with negative x plus 80 divided by 16 is 5. And it's equal to 0. So now we can set the 16x equal to 0 Dividing by 16 on both sides gives us x equals 0 seconds. And negative x plus 5 equals 0. Add the x to both sides. And we get x equals 5 seconds. And so what does that mean? What does that signify in terms of the soccer ball? This first solution, x equals 0, is when the ball's being kicked. Whoopsie. Got a little too close to my edge there. And the solution x equals 5, so that's 5 seconds after the ball's been kicked, and so it's when the ball hits the ground. And we want to graph this function on our graphing calculator, and they give us the window to use. We want to graph it from 0 to 5 on the x-axis, 0 to 100 on the y-axis, and then we want an x scale of 0.5 and a y scale of 5. So we want to go in and change our function, so click the y equals button and then hit clear, and that will clear out the function that we had in there from before. And so we want negative 16 x squared and then plus 80x. And then we want to change our window, so click on the window button. We want to go from 0 to 5 on the x-axis. And x scale 0.5 is okay, and then we want to go from 0 to 100. And the y scale was 5 that they wanted. And so then hit the graph button there. And that gives you a nice graph of this function. And so the results from A and C, so we had after 2 seconds, the height was 96 feet, and also that our intercepts are at 0 and 5. So I think the easiest way to do that would be to look at a table. And so let's go into the table. So the table is written in blue right here. That means that you have to click the second button and then hit graph. And so now I'm in my table, and I'm going to go into table set because I had been monkeying around with this and changed some things. So I want to start at 0, so this says table start 0, and then change table 0.5, and then independent auto, you want both of these set to auto. So I need to arrow down till I get to the dependent, and I want to just hit enter because it's flashing on auto right now. We'll change that back to auto. Okay, so now I'm going to go back to my table. So second graph gets you back to your table, and now you see it has this table filled in. It starts at 0, it goes up by 0.5 each time, and so we have the 0.00. We have the 0.50, that's where we said our intercepts were, so we got that correct. And then the other part to this was, what was the other part to this? Part A was at x equals 2, we have a height of 96 feet. So you see at 2 here, we do in fact have 96 for our height. And so that verifies all of our information. That's the end of this video. Let me know if you have any questions. Thanks.